Could you imagine a world where robots and vehicles operate independently without human intervention? Well, we are not far from that reality. The concept of autonomous systems is not new. It traces its roots back to ancient times when inventors created automata, self-operating machines often powered by water or wind. These devices, though primitive by today's standards, were the forerunners of modern autonomous systems. They astounded audiences with their seemingly autonomous actions, from automatic doors in ancient Greece to intricate mechanical dolls in medieval Japan. Fast forward to the Industrial Revolution and we see the emergence of automated machinery that could perform tasks without constant human oversight. These machines were not intelligent, but they demonstrated the possibility of automation on a grand scale. They were the workhorses that powered the factories, mills, and mines of the era, marking a significant leap forward in our journey towards autonomy. However, the real game changer arrived in the 20th century with the advent of computer-controlled systems. Computers brought a whole new level of sophistication to automation. They could perform complex tasks, process vast amounts of information, and even learn from their experiences. They started to control everything from industrial processes to home appliances, opening the door to the possibility of truly autonomous systems. The creation of the first autonomous vehicle, a modified cart that could follow a wire track, was a landmark moment. It showed that machines could navigate the real world, albeit in a limited way. This breakthrough paved the way for further advancements in autonomous navigation, leading to the development of robots and vehicles capable of complex decision-making and adaptation to unpredictable scenarios. These developments were just the beginning. Over the years, rapid advancements in artificial intelligence, sensor technologies, and computing power have pushed the boundaries of what autonomous systems can do. Today, we are on the cusp of a new era where autonomous robots and vehicles are becoming an integral part of our lives. This was the inception, the dawn of autonomous systems, setting the stage for today's sophisticated AI-driven robots and vehicles. From basic machinery to AI-driven systems, the evolution of autonomous technology has been remarkable. The journey began in the early 20th century with the introduction of autopilots in aircraft. This was a monumental step as it marked the first instance of machines taking over human tasks, albeit in a limited capacity. As the decades rolled by, the concept of autonomy started seeping into other domains. The late 20th century saw the birth of autonomous vehicles, initially in the form of robotic rovers designed for space exploration. These early explorers, like NASA's Sojourner, were rudimentary in their abilities, but they laid the foundation for the autonomous systems we see today. As we stepped into the new millennium, the advancements in artificial intelligence and machine learning started to revolutionize autonomous systems. Algorithms like deep reinforcement learning, DRL, and simultaneous localization and mapping, SLAM, were developed. DRL allowed machines to learn from their environment and improve their decision-making abilities, while SLAM provided them with a sense of location and mapping, enabling them to navigate complex environments. Then came the era of sensor fusion technology. Autonomous systems began integrating multiple sensors such as LiDAR, radar, and cameras to enhance their perception capabilities. This led to a better understanding of their surroundings and safer navigation. The data from these sensors were processed in real time using advanced neural networks, allowing the systems to identify objects, predict behaviors, and make informed decisions. The next leap in the evolution was the push towards energy efficiency and sustainability. Electric and hybrid autonomous vehicles became more common, and research started focusing on renewable energy sources for robots, such as solar and wind power. The most recent developments are in the field of ethics and regulations. As autonomous systems become more prevalent, there is a growing need for ethical guidelines and regulations to ensure their safe and responsible use. This evolutionary journey has brought us to the cutting-edge autonomous systems we see today. From self-driving cars to delivery robots, autonomous systems are now a part of our everyday lives, and they continue to evolve at a rapid pace. In the present day, autonomous systems are not just concepts, but reality, impacting various sectors. Let's begin with transportation. Autonomous vehicles are reshaping the way we think about personal mobility and public transport. From self-driving cars to autonomous buses and taxis, these AI-driven machines navigate complex environments, improve decision-making in real time, and adapt to unpredictable scenarios, all with the goal of making our roads safer and our commutes more efficient. Next, let's consider logistics. Autonomous delivery robots, both on sidewalks and in the sky, are becoming increasingly common. These machines are at the forefront of a revolution in logistics, optimizing delivery routes, reducing human error, and ensuring that goods reach their destinations swiftly and safely. Healthcare is another sector experiencing the transformative impact of autonomous systems. Robotic surgical assistants, for instance, use advanced AI algorithms and sensor fusion technology to perform delicate procedures with precision and consistency. Autonomous systems also assist in patient care, from medication dispensing robots to AI-driven monitoring systems that can predict and respond to a patient's needs. In agriculture, autonomous systems are driving a new green revolution. Self-driving tractors, automated irrigation systems, and drones for crop monitoring and spraying are just a few examples. These systems utilize the latest in sensor fusion technology and AI algorithms to optimize farm operations, increase crop yields, and reduce environmental impact. Even sectors like energy and sustainability are harnessing the power of autonomous systems. From solar-powered drones to wind-powered underwater vehicles, these autonomous machines are exploring new ways to harness renewable energy sources, contributing to a more sustainable future. In the realm of research and exploration, autonomous systems are going where no human can. Deep-sea exploration robots, Mars rovers, and satellite systems autonomously navigate and map their environments, pushing the boundaries of our knowledge and understanding of the universe. These are just a few examples of how autonomous systems are transforming our world. Like any technology, autonomous systems come with their own set of challenges and ethical considerations. Firstly, let's dive into the challenges. Safety and reliability are at the forefront. Autonomous systems must be able to respond correctly in unpredictable situations. For instance, an autonomous vehicle must be able to react appropriately to a sudden obstacle on the road. This requires rigorous testing and the ability to handle a vast array of scenarios known as edge cases. In addition, fail-safe mechanisms need to be in place to handle situations when the system encounters something it can't handle or makes a mistake. Cybersecurity is another critical challenge. Autonomous systems, being heavily reliant on software, are vulnerable to hacking and other forms of cyber attacks. This could have serious implications, especially in the case of autonomous vehicles where lives could be at risk. It's crucial to build robust security measures into these systems to protect against such threats. Now let's turn our attention to the ethical considerations. Privacy is a significant concern. Autonomous systems often rely on collecting and processing large amounts of data to function effectively. This could include personal information, which raises questions about how this data is used and who has access to it. Accountability is another ethical issue. If an autonomous system makes a mistake leading to harm, who is responsible? The creators of the system, the owners, or the system itself? This question becomes especially complex when we consider autonomous systems powered by AI, which can learn and adapt over time. Lastly, bias is a concern in AI-driven systems. AI learns from data, and if that data contains biases, the AI can perpetuate and even amplify those biases. For instance, facial recognition systems have been found to have higher error rates for certain demographics due to biases in the training data. Addressing these challenges and ethical considerations is crucial for the widespread adoption of autonomous systems. And with that, we're paving the way for a future where autonomous systems are an integral part of our everyday lives. So, what does the future hold for autonomous systems? Imagine a world where autonomous systems are woven into the very fabric of our daily lives. Advanced artificial intelligence algorithms, such as deep reinforcement learning, are set to revolutionize autonomous navigation. These systems will be capable of making real-time decisions, adapting to unpredictable scenarios, and navigating complex environments with the precision of a seasoned explorer. Simultaneous localization and mapping, or SLAM, will enable robots and vehicles to understand and map their environments while tracking their locations. This technology will be like giving autonomous systems their very own internal GPS, but one that is constantly learning and adapting. Sensor fusion technology will also see significant advancements. Picture a symphony of LiDAR, radar, and cameras working in harmony, providing a comprehensive perception of the environment. Advanced neural networks will process this data in real time, allowing autonomous systems to identify objects, predict behaviors, and make informed decisions. Sustainability is also on the horizon for autonomous systems. The push towards electrification in autonomous vehicles will see the rise of electric and hybrid options, featuring advanced battery technologies and charging infrastructure. We'll also see research into renewable energy sources for robots like solar-powered drones or wind-powered underwater vehicles. As these technologies advance, ethical considerations and regulations will need to keep pace. Matters of privacy, accountability, and bias in AI will be at the forefront of discussions. Different regions will frame regulations to safely integrate autonomous systems into public roads and airspace, creating a global regulatory landscape. In the end, the future of autonomous systems is about more than just technology. It's about creating a world where these systems enhance our lives, making them easier and more efficient. From autonomous delivery robots to self-driving public transport, the possibilities are endless. The future of autonomous systems is promising, and as we continue to innovate, we move closer to a world where robots and vehicles operate independently, making our lives easier and more efficient.